Let me talk a little bit about how you can fix the orbit characteristics in here. This is the most commonly missed thing. Okay. Ultimately, you're going to find the first thing you want to do is pick a radius. Okay. Now let me just give you a clue. Whoops, there's no E on radius. Okay, let me give you a clue. Your radius has to be bigger than the planet. Okay. So for example, for Earth. The Earth's radius is 6.372 times 10 to the 6th meters, right? I don't know, maybe add 1,000,000 meters to that, okay? Some people were orbiting at like 1,000 meters above the surface of the Earth. And the problem with that is, of course, Mount Hood is 3,000 meters tall, right? Okay. So let's say you want to orbit 1,000 miles above the thing. Maybe that's what you meant. You're going to go that plus 1,000 and then convert that to meters, right? So 1609, right? This is how many meters per mile. Maybe that's how many miles you have. Okay, keep in mind that you really want to orbit the Earth above 100 miles. And even then, you probably want to orbit farther than that, okay? Because the atmosphere goes up to 100 miles. There's enough atmosphere to slow down the space station, right? Okay. So pick your radius. Once you've picked your radius, okay, step 2, you can find your velocity. If you don't want to set up the complicated orbit equation, you can just do this. You can go velocity is square root of gm over r. Now remember, that's the mass of the planet you're orbiting, not the mass of your space station. Okay, the satellite mass. In this case, your space station is a satellite, and the satellite mass cancels, right? So now we've got the velocity, right? We've got the radius. To find the period, you could set up that orbit equation. You could also just use the simple relation that velocity is circumference, right? You know your radius, right, divided by period. So if you know the velocity, circumference divided by velocity would be period. Okay, so now you've got your period. And then to find the centripetal acceleration, most kids did this. They did v squared over r, because you got your velocity and you've got your radius, right? So that's one way to do it. I'm going to give you a clue. Your centripetal acceleration, if it's above Earth, is less than 9.81, okay? The farther away you go, the less it is. Out by the moon, it's really small, okay? So you know, that's how I know it was wrong if it was 10,000. Okay, so centripetal acceleration, that's one way to get it. And then force of gravity, this is what we're looking for. Force is g m1. That'll be your planet's mass, mass of your satellite, of your space station, right? So this is the planet, the space station, and then your radius squared. Now, of course, if you get the wrong radius, all of these are wrong. That's why the most common bad score on this was just 0 out of 10. You didn't have anything right because you picked the wrong radius. Okay. So plug this in. This will, be a fair amount of force. The other way, by the way, to find your centripetal acceleration is just whatever that force is divided by the mass of your space station, right? You could do it that way. You could check. This had better, v squared over r better be pretty close to the force you get from this divided by the space station's mass, okay? So force of gravity, we got that. We got the centripetal acceleration. When you do this, stick this on a separate sheet of paper. Keep that cover sheet on the front. Put this on a separate sheet of paper on the back.